All right, well, the joys of a word problem while we're studying sum and difference of angles identities. Let's see, we got the harmonic motion of an object can be described by x equals 4 times the cosine of 2 pi t minus pi over 4. Well, there's our function. Where x is the distance from the equilibrium point. That idea of an equilibrium point might be interesting. In interest, and t is the time in minutes. Time in minutes, that's going to become important. Find the exact distance. Now, exact, anytime you see exact distance, if you're going to have a pi or some type of square root or something like that, you don't need to give an approximation. You need to leave it like it is. From the equilibrium point at 45 seconds. Well, I got to do some thinking on this. Let's first think about this. Let's think about this equilibrium point. And I'm just going to kind of draw a crude coordinate plane. And I could think about the equilibrium point as being lying on where the object is lying on the x-axis, so to speak. In other words, it's at rest at that point. All right, and we're trying to find where x is the distance from the equilibrium point. Well, let's see. Something else I need to think about is this 45 seconds. I'm told that t is in minutes, but this is 45 seconds. And I've got the variable t up here in my function. So I probably need to anticipate, I need to convert this 45 seconds into minutes. Well, let's see, there's 45 seconds and there's 60 minutes and a minute, 60 seconds in a minute. And I could reduce this, let's see, 45 over 60. Well, that's the same as 3 over 4. Okay, I believe I'm beginning to start to work here. So we're going to say that x is equal to 4 times the cosine. Let's just fill in what we know and see where we go from there. 2 pi times 3 over 4 minus pi over 4. And I'm going to stick with the inside here for a minute. So x then is equal to 4. And let's see, we got the cosine now of, well, let's see, 2 pi times 3 over 4. That's going to give me 6 pi over 4 minus pi over 4. And I could say that that's going to equal 4 times the cosine of 5 pi over 4. This is interesting, really, that it's in the sum and difference of angles identity, because you know what? 5 pi over 4, I kind of know where 5 pi over 4 is. 5 pi over 4 is going to lie in this third quadrant down here. So my cosine is going to be negative, but we're really just looking from up above or below the equilibrium point. Well, I'm going to ask the question, do I know what the cosine of 5 pi over 4 is? And I do. It's the square root of 2 over 2. So let's see, x now is equal to 4 times the square root of 2 over 2, and that's negative. Well, we can simplify this a little bit to where x is going to equal negative 2 square root of 2. Or let's answer the question actually as it is. We can say then that the exact distance from the equilibrium point in inches, where the cosine is 2 pi t minus pi over 4 at 45 seconds, it's going to be 2 times the square root of 2 inches below the equilibrium point. And guess what? We are done.